So today I have Gerald with us, who is the Chief Technology Officer of the company that we're currently speaking about. He is passionate about developing machine learning applications at work and making sure that he understands the intricacies of how different projects work together. Let's welcome Gerald on 10 Minutes of Hiring Wisdom, where he will tell us about what his company does, where he's working, and what his day-to-day routine looks like. Hi, Gerald. How are you doing?
Hi. Yeah, so uh, my company is called Brainome, and what we do is we do machine learning that doesn't require any coding and any interaction, and it's based on a brand new theory that I actually developed. I'm actually by profession more a career scientist, and I teach at UC Berkeley data science as well. And
Okay.
so the interesting part is that we one thing I figured out is that machine learning should not just be, hey, let's build a model. It should be, let's measure out the data and then build the model based on measurements, just like any other engineering discipline. Builds a car, an airplane, or whatever you build, it starts with measurements. So we start with measurements. And the result of that is that we can measure out the data and automatically create models for the data that we can control the generalization and the accuracy. We can control a lot of things that are currently mostly guessed. And in the end, our models are 2 orders of magnitude smaller and 2 orders of magnitude faster for the same accuracy compared to, for example, Google's AutoML or other state-of-the-art tools.
Wow. And how did you come up with this theory? Like, where did the idea come from? Was it a lot of hypothesis testing? Was it just inspiration that came from nowhere? Where did the idea come from that you wanted to develop a theory specifically?
Well, the idea was actually kind of interesting. It came from the fact that I was just being a career machine learning researcher. I've done machine learning since 2001, so way before it was cool. And in fact, if you teach, the cloud services are usually quite nice. So they asked me, so I asked them and said, hey, I have some students who want to run some deep learning experiment. Can we get some compute time for free? And of course, they usually say yes, but they ask one simple question, which is, how much do you need? And I figured out, actually, I don't have the answer for that. I don't have the answer for how much I need, because data science and machine learning projects are currently this endless bucket where you basically just pour money in and you never know when you're done. And I was like, this is not right. We need to do something about this. And this is the whole reason we have engineering and plan the house before we build it, so we can actually figure out how much budget we need. And so that was the creation moment of, like, how do we measure out information such that we can plan out what a model we need. Right?
Okay, wow. And you mentioned that you teach at UC Berkeley. How is it working as a chief technology officer for a company while while teaching students? Like, how does that go hand in hand?
It goes very well hand in hand. So I mean, we need different talent, obviously, and but also because it's a very research heavy company, we cannot just hire anybody. I mean, it's like, basically you need to be educated in the theory. I mean, for different roles, obviously, right? I mean, there's obviously roles we hire normally, right? For example, right now we're building an Excel plugin so that basically machine learning can be done within Excel, and there's no further it just works. And for that, obviously, we would need an Excel expert, for example. And that you can't find in university. But in a university, you can find sort of people that I can educate on the theory, and then bring the research and propel the research forward. And in fact, my current class is called Experimental Design on Machine Learning. Has 100 graduate students. It's all graduates. For a graduate class, it's extremely large.
Wow.
And it's basically, there's something there that people understand, that, yeah, measurements are missing. We need to be engineers about our model building.
Okay, well, and how do you get students excited? Because I think with data science specifically, there's so much in the unknown, and like there's a lot of variables that you need to take into account. And a lot of people don't exactly like working with the unknown. So, how do you get students excited, being like, okay, this is the idea, this is what you have to work on to make sure that you can like hire the right talent for your company, for instance?
So that is the trick. The trick is that I solve these unknowns. And the principal idea is not to just, here's some math like k and n, let's try it. No. The principal idea is, we have a notion of information, and information is physical. And physicists have built models for hundreds of years. and they know exactly how to build models. They know what's a good model, what's a bad model. They know why Occam's razor is important and not just a philosophical concept that needs to be discussed. They know that there's methods like statistical mechanics to actually understand black boxes and so on and so forth. And I took these methods together to understand machine learning as a black box, but also then it gets less and less of a black box the more you actually understand. And then there's ideas like exponential decay. There's ideas like entropy, obviously, right, is the most important one, because ultimately what we're really doing is we just need to measure the entropy of the function implied by the data, right? And so I built this up from scratch, but it also starts, for example, with a working definition of intelligence. Many people are like, okay, there's so many definitions of intelligence. True, there are, but let's take one that works for machine learning so we can actually work with it. And the original that worked for me is actually the one from Binet and Simon who created the IQ test. And from 1904, what they said is intelligence is the ability to adapt. And it turns out, yeah, what we're doing in machine learning is we adapt the finite state machine, which is our computer, to the function of the table that's implied by the table. Well, what is the table? The table is our training data, right? Where all you have your data and your label, another data and your label, another data and your label. It's always a table. And so it
Wow.
becomes a whole theory from that you can start from scratch and teach from scratch, and then people go, ah, my God, why are we just trying KNNs? Why didn't we just measure this out, right? And there's issues like the curse of dimensionality, for example. The curse of dimensionality is only a curse if you don't measure the dimensionality. You should measure it and know the information limit for your machine learner so you can actually adjust accordingly. And the statisticians have tried a lots of methods to adjust, like the Bayesian information criterion and so on. These are all cool methods. I'm not saying these ideas were wrong. These ideas were right, but they lacked one thing, which is measurement. There's no unit out of BIC or AIC, but there is a unit out of entropy, and that's the bit. And so once you start measuring and you start unifying everything in units, things become a lot clearer. That's the
That
idea.
makes
That's what I teach in the class, and that's what's used in the tool that we create and also distribute and have enterprise sales for.
I love that approach that you always understand that there's always room for improvement, because I mean, yes, a lot of theories do exist, but there's always going to be something that you could work on to make it better. And you clearly did that. You're getting students passionate about your learning theory, and seems like you're doing a really good job because you started your own company and things have been going well. So the last question, Gerald, would be: you mentioned that your company is waiting for another round of funding. So when is exactly this funding going to happen, and when exactly is your company going to start hiring for people who are interested in research, who are interested in machine learning and AI specifically? What exactly are the next steps?
So, well, the funding happens when it happens. That's always that's always the thing. I mean, anywhere between now and whatever. I mean, we're working on it. And once we start hiring, which is gonna probably be in the next couple of weeks, what we really need is an Excel expert, somebody who's really helps us with Excel, but also we probably want to integrate with Snowflake. We also want to integrate with the Google Sheets and other sort of spreadsheet programs, so that literally you can just select your data and your label column and say, give me a model. And it's an extremely powerful way of doing this because it's going to be not cloud connected. It's going to be on your own computer. You don't have to use the cloud. You don't have to transfer your data to anybody. It's private. And then you can actually play around in your table and see, okay, what if this value changes? What would the prediction be, right? So you actually your data, you take your data and convert it into an expert, because now you can ask questions by just playing around with the values.
Well, that sounds efficient. That sounds very productive, and it sounds amazing, specifically because you can change the variables in front of you and see how one
Exactly.
variable will have an effect on the other, possibly establishing correlations or even causation
And
if
then,
you want at the
yeah,
end of the day.
I
But
was just
Gerald,
saying, then we target the
sorry, go
tool
ahead.
not to data scientists, but we target the tool to like the CFO, or it's like really like, I mean, ultimately our goal is to reach the 2 billion spreadsheet users that there are.
I'm sure you will. With that ambition and the research that you've done, I'm pretty sure you will. But other than that, Gerald, it was an absolute pleasure having you as a guest. Thank you so much for coming on the show, sharing about your theory, how you came up with this idea. It definitely sounds a lot of amazing work that's being done there, and if your hiring starts soon, you can reach out to me and we can definitely help you
Okay,
in
thank
finding
you.
the right talent. Thank you
Bye.
so much.